On page 553, at the bottom, or at least on the bottom half of the page, let's do a little reading. A 30, 60, 90 triangle is another special right triangle, or right triangle with side lengths that share a special relationship. You can use an equilateral triangle to find this relationship. So like when we did the 45, 45, 90, we started with a square and drew a diagonal in, and that led us to figure out that whatever the length of the leg was times the square root of 2, that was the length of the hypotenuse. So we're going to do a similar thing here, but we're starting with an equilateral triangle. Because when an altitude is drawn from any vertex of an equilateral triangle, two congruent 30, 60, 90 triangles are formed. So they started with this, and then they drew in an altitude. Okay? You know that an altitude starts at a vertex and it's perpendicular to the opposite side. So we know that's a 90-degree angle. Since the red one's an equilateral triangle, that's 60 degrees, that's 60 degrees. And then, doesn't that mean that that's got to be 30, so that in the triangle on the left, the angles add up to 180, and that's got to be 30 for the same reason. So we ended up with two congruent 30, 60, 90 triangles. And we know they're congruent because that's congruent to itself, it's equilateral, so those are congruent to each other. So by side angle side, we know they're congruent to each other. All right, so that's where the figure comes from. Now, it says in the figure shown, triangle ABD is congruent to triangle CBD. So segment AD is congruent to segment CD. So once we've got the triangles congruent to each other, corresponding parts have to be congruent. So we know that those two segments are congruent. Okay? Now, if the length of AD is X, so let's just ignore that one for a minute. If the length of AD is X, I think I'd rather start the other way. If the length of each side of this equilateral triangle is 2x, let's start with that. And we're calling it 2x to avoid having a bunch of fractions in our work. Okay? Because if the length of each side of that equilateral triangle is 2x, since that segment's congruent to that segment, doesn't each of those have to be x? For instance, if the length of each side was 10, and then you divide that 10 into two congruent parts, doesn't each part have to be 5, half of 10? So if they're all 2x, and you divide that one in 2, each half has to be x. So that gives us, the x for both of those lengths, and it gives us the 2x for both of those. Okay? All right, now, let's just concentrate on one of these for a minute. Okay? That's a 30, 60, 90 triangle. Are those legs congruent to each other? They're not, are they? Okay? So unlike yesterday, when we had congruent legs, and we just said leg times square root of 2 equals hypotenuse, that we can't do that. So we need to now talk about short leg and long leg. Notice the short leg, I mean that leg right there is obviously shorter. It's opposite the 30 degrees. The long leg is opposite the 60 degrees. Doesn't that make sense? Since small opposite small, large opposite large, that the shorter leg would be opposite a smaller angle than the larger leg. All right? So the short leg's opposite the 30, the long leg is opposite the 60. Now, we're going to figure out a relationship between the short leg and that long leg. But I already see a relationship between the short leg and the hypotenuse. Don't you? Isn't the hypotenuse whatever the short leg is times 2? If the short leg is x and the hypotenuse is 2x, short leg times 2 gives you the hypotenuse. All right, so we've already got one relationship figured out. Now let's figure out the relationship between the short leg and the long leg. And we're going to use the Pythagorean theorem to do that. Okay? Now, they called the long leg A. So I will too. So there's A. So the length of the long leg is A. So one leg squared, A squared, plus the other leg squared, the short leg squared, X squared, equals the hypotenuse squared. The hypotenuse is 2x. You with me on setting up the Pythagorean theorem? All right. So a squared plus x squared equals 4x squared, because 2x times 2x is 4x squared. Kind of like the problem we did just a few minutes ago. Subtract x squared from both sides, and we get that. Take the square root of both sides, and we get that. Simplify that square root, because that's the square root of 3 times the square root of x squared, so that's x square root of 3. And look what we have. Whatever the length of the short leg is, times the square root of 3, that equals the length of the long leg. Okay? Now, the book puts all of this into a theorem. In a 30, 60, 90, the hypotenuse is 2 times the short leg, and the long leg is the square root of 3 times the short leg. I want you to write it in your notes like this. So we're doing something similar to what we did yesterday, but in a 30, 60, 90, since the legs are not congruent, we have to pay attention to which one's the short leg and which one's the long leg. So we have a 30, 60, 90 right triangle. The hypotenuse is opposite the right angle, like the hypotenuse always is. The short leg is opposite the 30 degrees, and the long leg is opposite the 60 degrees. That's the way it's always going to work. Now, in the past, some students have been confused by this. We call the long leg the long leg. It's not the longest side in the triangle, is it? It's the longest of the two legs. The hypotenuse is still the longest side of that triangle. The hypotenuse is always the longest side of the triangle. Okay? So the short leg is the shortest side, the long leg is the next, and then the hypotenuse is the longest side. All right? So you got to remember that. Now, here's what we've learned. The hypotenuse equals the short leg times 2. So whatever the length of the short leg is, multiply it by 2, and now you know the length of the hypotenuse. We also know that the long leg equals the short leg times the square root of 3. So both of those equations come from the work we did just a minute ago when we started with that equilateral triangle and drew the altitude in. All right, that's where those two come from. We okay with those two? So look, since we have the hypotenuse as the short leg times something, and we have the long leg as the short leg times something, don't you want to know the length of the short leg to start with? That's what you want, okay? They're not always going to give us the short leg first. But if they give us the short leg, let's say the short leg is 100. Well, then the hypotenuse is 100 times 2, 200. And the long leg is 100 times the square root of 3, which we will just call 100 times the square root of 3. So if you know the length of the short leg, you can find the length of the other two sides of the triangle fairly easily. But what if we don't know the short leg? Well, then we need to find it, okay? And we can find it by using these equations, just solving them for the short leg. If I take that equation and I solve it for the short leg, in other words, get the short leg by itself, wouldn't I divide both sides by 2? Wouldn't that get the short leg by itself? So that means that the short leg equals the hypotenuse divided by 2. So, if they give you the hypotenuse first, all you got to do is divide it by 2, and now you know the short leg. Once you know the short leg, is it easy to figure out the long leg? Mm-hmm. If the hypotenuse is an even number, like it's 8, you then go ahead and simplify it. If it's got a radical in it or an odd number, just leave it over 2. Okay? But what if they give us the long leg? How would I solve that one for the short leg? What would I do to both sides of that equation to get the short leg by itself? Divide it by the square root of 3. So short leg equals long leg divided by the square root of 3. Now, you will never use all 4 of these equations on one problem. And it's also not quite as obvious which ones to use as it was with the 45, 45, 90. But when you take all of that together, if you know the length of one side of a 30, 60, 90 triangle, you can find the length of the other 2 sides. Okay? Remember, these properties only apply to a 30, 60, 90 triangle. So if I draw another triangle, if we don't know that's a 30, 60, 90, do not apply these equations to it. Okay? So that's a common mistake, is we're going to do a bunch of 30, 60, 90s today. And so then every time you see a triangle that looks like it might be a 30, 60, 90, if you don't know that it is, you got to resist the temptation to treat it as a 30, 60, 90. Okay? You've got to know it's a 30, 60, 90 before you can apply any of those 4 equations. All right. Now, kind of like yesterday, where there's really not enough examples in your assignment, let's do a few examples from the book. So I got these from the bottom of page 554. You don't have to draw the figure, but write the work down with me so that you've got examples to go by when you do your own here in a few minutes. All right, 3A. Well, that's fairly obviously a 30, 60, 90 triangle, considering the angles are labeled as 30, 60, and 90. So we know it is. We're supposed to find x and y. So we're supposed to find the other 2 sides of that triangle, or the lengths of the other 2 sides of that triangle. So we look at 3A, and we see here, you know what, I think I'd rather do 3C first. Let's do 3C first. Sorry. You'll thank me later. Let's do 3C first. Because on 3C, that 21, that 21, is that the length of the short leg, the long leg, or the hypotenuse? It's the short leg. How do you know it's the short leg? Because it's opposite the 30 degrees. All right? I mean, and try to resist the urge to go by how it looks, because what if I drew the triangle instead of copied it out of the book? All right? So it's the short leg because it's opposite the 30 degrees. Now, that means that I can use, since I know the short leg, I don't have to worry about those 2 equations, do I? Those are the ones I use when I don't already know the short leg. Since I know the short leg is 21, then I know that the hypotenuse equals short leg times 2. So the hypotenuse equals, so which one of those is the hypotenuse, x or y? X. So the hypotenuse equals the short leg times 2. So what's the length of the hypotenuse? 42. But we also have to find the length of the long leg. So y is the variable that represents the length of the long leg. And I know it's the long leg because it's opposite the 60. I knew x was the hypotenuse because it was opposite the 90. So long leg equals short leg. What's the short leg? 21 again, times the square root of 3. And we'll just leave that one like that. So x equals 42, y equals 21 times the square root of 3. Questions? All right, let's work our way backwards. Let's do 3B. Are we positive that 3B is a 30, 60, 90? Yeah, the missing angle's got to be 30. Okay? Now, this time, though, we don't know the short leg. All right, that's the 30. So I wish I knew the length of that side right there, but I don't. If I don't know the length of the short leg, I find the length of the short leg. Okay? So we need to find the length of the short leg. And look, there's two different equations for us to find the length of the short leg. I have to decide which one is the one that's useful. Look what I do know. What I do know is that that's 10. Is 10 the short leg, the long leg, or the hypotenuse? It's the hypotenuse. So I need to find the short leg by using the equation that has the hypotenuse in it. Does that make sense? Okay. So the short leg, which we're calling x, equals the hypotenuse 10 divided by 2. And that one we can simplify. So x equals 5. And now that we know the short leg is 5, we can find the long leg fairly easily, can't we? Now that we know the short leg, we go back to this equation to find the long leg. So the long leg, which is called y, equals the short leg times the square root of 3. All right, so does 3b make sense to you? Any questions? All right, do 3a. All right, here's my thought process. I look at the triangle, and it is a 30, 60, 90. And then I think, okay, which length do I know? The only one I know is a 12. All right, so is 12 the short leg, the long leg, or the hypotenuse? Well, it's opposite the 60, so it's the long leg. So I know the length of the long leg, and then I need the short leg. If I don't know the short leg, that's always what I find next, or find first, okay? If I don't know the short leg, I find the short leg. So, since I know, so I can either use that one or that one. I know the long leg, so that's the one to use, isn't it? So the short leg, which is opposite the 30, so the short leg is x. So short leg equals long leg divided by the square root of 3. And now we've got the short leg. We need to get the hypotenuse, okay? So the hypotenuse is called y because that's the length that's opposite the 90 degrees, so that's the hypotenuse. So now I'm using this one. Hypotenuse equals the short leg, 12 divided by the square root of 3, times 2. And I can simplify that a little, right? 12 times 2 is 24. So x is 12 divided by the square root of 3, and y is 24 divided by the square root of 3. Neither of those answers will be the answers that you would find in the back of the book if you checked them, because they would put it in simplest radical form, and we're not going to. So that's the answers we're going to come up with. By the way, some of you have calculators that automatically put things in simplest radical form. That's fine. You don't have to unsimplify it to make it match my answer. Okay? All right, did y'all get 3A okay? All right. Let's take a look at another one that's not from your assignment. Let's take a look at number 4 at the bottom of page 555. Now, on this one it says, the top of the aquarium coffee table shown is an isosceles right triangle. Which are we dealing with? 45, 45, 90 or 30, 60, 90? Yeah, if it's an isosceles right triangle, that's a 45, 45, 90. Okay? So, that's a 45, 45, 90. So the table's longest side, segment AC, measures 107 centimeters. 107 for segment AC. If that's the longest side, that tells me for certain that's the right angle, doesn't it? Okay? What is the distance from vertex B to side AC? Ooh. How do you find the distance from a point to a line? By drawing a segment from the point perpendicular to the line and finding the length of that segment. Okay, that's the distance from B to side AC. And then, what are the lengths of the other two sides? All right, I think I'll find that first. Now, I think it's a little easier. I want to keep in mind what the questions are. I'll move it down here. All right, so I've got 45 degrees there, 45 degrees there. I know it doesn't look like it because it was a tabletop. We were looking at it from an angle, okay? So 45, 45, and the other's the 90. So the last question was, what are the lengths of the other two sides? Well, can't I just use my 45, 45, 90 equations here? I know the hypotenuse is 107, so wouldn't each leg equal 107 divided by the square root of 2? So, I answered the last question first. The length of those other two sides, 107 divided by the square root of 2. And now, what's the distance from B to side AC? So I'm going to call that X. What's that distance? All right, you need to remember something here. When I draw in that altitude, okay, remember that in an isosceles triangle or an equilateral triangle, when you draw in an altitude to the base, it bisects the base. That's only true if it's isosceles and you're drawing it from the vertex to the base, okay? Well, what's half of 107? What is it? 53.5. Now, look at this triangle here. What kind of triangle is that? Right. It's a right triangle, and it's a 45, 45, 90. Doesn't really look like it, but that angle's got to be 45, so we're kind of back in business for finding X, aren't we? All right. If one leg of the 45, 45, 90 is 53.5, what's the other leg of the 45, 45, 90? 53.5. So, distance from B to segment AC equals 53.5. Questions? You think you got it? Did you follow what I did? Okay. And look, isn't that drawing a pretty good example of why you can't always just go by how it looks? Look, I didn't even mess up the drawing. I traced it right off of there. But since it came from a real object, your point of view, your perspective, made it look a little different than you were expecting. Okay? All right. Turn to page 556. and do number 4. And let's do 4 together. All right, it is a 30, 60, 90. The missing angle's got to be 30. Let's identify which side we already know, which length we already know. That 16 radical 3. Is that the short leg, the long leg, or the hypotenuse? It's the hypotenuse. If I don't know the short leg, the first thing I'm doing is finding the short leg. So I know the hypotenuse, and I want to know the short leg. That means I use equation number 3 there, doesn't it? Okay? Now, which variable represents the short leg, the x or the y? The y. So short leg equals hypotenuse, 16 radical 3, divided by 2. Now, you can leave it like that, but whenever two numbers, how do I say this? You're not allowed to divide a number that's under a radical with a number that's not under a radical. But 16 is just a number. It's really 16. It's not the square root of it or anything like that, is it? So what's 16 divided by 2? So we can simplify that to get 8 square root of 3. Now that we know that length, I can get the long leg. So what variable represents the long leg? X. So long leg equals short leg, 8 square root of 3 times the square root of 3. We can simplify this a little bit. What's the square root of 3 times the square root of 3? It's 3. Okay? Because remember we talked about this before. It'd be the same thing as the square root squared and the square root squared. The square root and the square cancel each other out. And so our final answer is x equals 24. We okay with number 4? Number 5. Is this a 30, 60, 90? Why, certainly it's a 30, 60, 90. All right, so which side length do we know? The long leg, the short leg, or the hypotenuse? Short leg. So we ought to be in business this time, right? So go. Did you get what I got? Okay. Now, you don't have to write down 7 times 2 if you don't want to. Okay? Number 6. Is this one a 30, 60, 90? Yeah. Which side do we know? Which length do we know? Long leg. So before we do anything else, we got to find the short leg. Which equation are you going to use? Number 3 or number 4? Why number 4? Because we know the long leg. Okay, so which variable represents the short leg, the x or the y? So short leg x equals long leg 12 divided by the square root of 3. We just did this problem, didn't we? Like one of the others is just like it. All right, now that we know the short leg, we're still missing what? We're still missing the hypotenuse. So we go to this equation. So the hypotenuse, which is represented by which variable? Hypotenuse equals short leg, 12 over the square root of 3 times 2. So y equals 24 over the square root of 3. All right. Any questions? All right, here's what I want you to do. I've actually decided to, ooh, I did have it there. Okay, no, that's what I wanted. So page 556, do 4 through 6, 18 through 25, 27, 30, 32, 34, 35, 37, 39, 40, 44, 50 through 54. Now, this will have some 45, 45, 90 stuff mixed in with it. So pay attention. Don't assume every triangle in the world is either a 30, 60, 90 or a 45, 45, 90. Pay attention to what you got and work on those.